Alright guys, here we go. We're doing number one. The question reads like this. You are studying a population of mice in a forest. Your data showed that these mice only appeared in blue and green fur coloring. After using Wikipedia, you found that the green fur is dominant over the blue color. Your data collected showed that you counted 48 blue and 214 green fur. What is the homozygous dominant phenotypic frequency? How many ticks will be heterozygous? Okay, so let's start out by filling in this chart that we're going to do every time. Okay, so let's go ahead and put our dominant on the top row. Right here, we'll put dominant, and we'll put our recessive right here, just so we don't get mixed up. And they told us that our green is dominant over the blue, so we'll put green up here, put blue right here. All right, and they told us that we have 48 green, and we have 214 blue. So what's our total population here? What's our total? What's our total right here? Is it going to be 262? All right. So we can go ahead and figure out our phenotypic frequency right away by taking this number divided by our total number. So it'll be like our part over our whole. So let's go ahead and do that. Let's go ahead and do 48 divided by 262. We should get 1.18. Let's go ahead and do that for this other one. The 214 divided by 262. We should get 0.86. And when you check yourself, you should be able to add this value and this value. You should be getting a 1 here. And we do get that. This plus this does equal 1. So that's your first check to make sure you're doing everything all right. Okay, so what we're going to say about this is we made this chart just for this number right here. We're interested in this number right here. This number represents Q squared. All right, if we're going to call that Q squared, then we can go ahead and find out what Q equals. All right, so let's go ahead and do that. Square root of this will equal Q. So we're going to say Q equals 0.927. Okay, and then we're going to go ahead and use this formula right here. P plus Q equals 1. And since we know what Q is, we can go ahead and solve for P. P equals 1 minus Q. So we're going to go ahead and plug this value here right into Q. And we're going to go ahead and say that equals 0.0726. Okay? So from there, we can go ahead and fill in the questions that we want to talk about. We can go ahead and talk about the homozygous dominant phenotypic frequency. So if you want to talk about that, we got to talk about what we're looking at with this population. We're going to go ahead and use this equation right here. P squared plus 2pq plus q squared equals 1. All right? And since we have a dominant and since we have a recessive relationship here with Hardy-Weinberg, we can go ahead and say that anywhere we see the big P, or anywhere we see P, sorry, not big P, anywhere we see P, we're going to say it's dominant. And anywhere we don't see P, so no P, we're going to say it's recessive. So let's go ahead and see where we see some P's here in this equation. We see P squared plus a 2PQ. So I'm going to go ahead and say what I see with my eyes is a P squared plus 2PQ. Now, we know what P is. P is this. We can just go ahead and put a square on that, 0.0726 squared, plus 2 times our P, which is this, 0.0726, times our Q, which is this, 0.927. And if we go ahead and do that, we're going to get a frequency of 0.14 or 14%. Now, let's go ahead and talk about the heterozygous population. We can go into the heterozygous population by using the 2pq. So let's go ahead and do that. We actually already have that right here. We have 2pq right here. 0.0726, 0.927, and that should equal 0.13, or 13%. So if we're gonna say that our heterozygous frequency is this, 13%, 13% of what? I wanna know how many mice are heterozygous. How many are 2PQ? So I'm gonna take that 13% or that 0.13 times our total population here, 262, and I'm going to get about 34.06 mice. This 06 cannot exist. You cannot have a 06.06 of a person, so you're going to have to round up no matter what you do. So we're going to say 35 mice are heterozygous. And that's how you go ahead and do number one.